Assalamualaikum and hi everyone. Today we will continue on lecture 4 of 6, 7.4 Ordinary and Simple Annuity. By the end of this lesson, students should be able to A. Determine the amount of annuity or future value. Annuity. What is annuity? An annuity is a series of periodic payments or deposits usually made in equal amounts at equal intervals of time. The payments are computed by the compound interest method such as annually, semi-annually, quarterly, or monthly. Examples of annuity are life insurance premium, pension, periodic saving, and buying of house on installment plan. Basically, there are two annuities, which is the first one is contingent annuities, in other words, life annuities, and annuities certain. If payments are made at the end of each time interval, then the annuity is called an ordinary annuity. So, the keyword that you should know here is annuity is about payment which is made in equal amounts at equal intervals of time. For further details about amount of annuity, let's hear explanation from Madam Salawati.
Amount of annuity. So amount of annuity denoted as S. So what is the amount of annuity? The amount of future value of an annuity is the value at the end of the term. That is, it is the sum of compound amount of all payments. Using this time scale, we may derive the future value for the annuity immediate. So let us look at the timeline. So we are going to use the formula for compound amount as equal to P1 plus I to the power of N. So all of these R will be our P, okay, principal, and this is our S, okay. So consider the first R, okay, the first R. The S is the compound amount is R1 plus I to the power of N minus 1. So this R will be compounded. Okay, will be compounded. Okay, so we get S equal to R1 plus I to the power of N minus 1. So this is our first S. Let's say S1. So this is our S2, S3, and so on. So all of these S, S1, S2, S3, and so on will be accumulated as S. So S is the accumulated amount. Okay. So S1, S2, S3, and so on will be accumulated as S. Okay, by adding all the S1, S2, S3, and so on, okay, so this S1 plus S2 plus so on, okay, so we have S equal to R1 plus I to the power of N minus 1 plus R times 1 plus I to the power of N minus 2 and so on. So this equal to a geometric series, okay. So our first term is R, the ratio, common ratio is 1 plus I, and the number of terms is N. Okay, so we know the formula for Sn for geometric series. Sn is A times R to the power of N minus 1 over R minus 1. So we substitute A equal to R equal to 1 plus I, Okay, so we have this formula. Therefore, the formula for the future amount of an annuity is given by this formula. So Sn equal to R 1 plus I to the power of n minus 1 divided by I. So after this, to solve the problem, we are going to use this formula. Let us look at the first example. Find the amount of an annuity of RM200 payable at the end of each month for 5 years if the interest rate is 10% compounded monthly. So first we have to list down all the information given in the question. So here we have the value for R equal to RM200, M equal to 12, T equal to 5 years, interest rate J equal to 10%, which is 0.1. Therefore, our N equal to 12 times 5 equals 60, and I equal to 0.1 divided by 12. So we know that S, the future value for annuity, is given by the formula R times 1 plus I to the power of n minus 1 divided by I. So substitute the value for R, I and n into the formula. We have 200 for R, 1 plus I equal to 0.1 divided by 12 to the power of n, 60 minus 1 divided by I, 0.1 over 12. So answer will be RM 15,487.41. Next example. A person plans to deposit RM1,000 in a tax-exempt saving plan at the end of this year and an equal sum at the end of each following year. If interest is expected to be earned at the rate of 6% per year compounded annually, to what sum will the investment grow at the time of the forced deposit? So first, we have to list down all the information given. So we have R equal to 1,000, J equal to 0.06, M equal to 1, therefore I equal to 0.06, and then N equal to 4. So S is given by R times 1 plus I to the power of n minus 1 divided by I. So substitute all the value. We have 1,000, 1 plus 0.06 to the power of 4 minus 1 divided by 0.06. So answer will be RM 4,374 and 62 cents. So let us move on to the next example. A teenager plans to deposit RM50 in a saving account at the end of each quarter for the next 6 years. Interest is earned at a rate of 8% per year compounded quarterly. What should her account balance be 6 years from now? And how much interest will she earn? So list down all the information given. R equal to 50, M equal to 4, T equal to 6, J equal to 0.08. Therefore, N equal to 4 times 6 equal to 24, and I equal to 0.08 divided by 4. S is given by R 50, times 1 plus I, 0.08 over 4 to the power of n, 24 minus 1 divided by I, 0.08 over 4. So answer will be RM 1521.09. How much interest will she earn? So the interest is given by S minus R times N. So S is 1521.09 minus R. R is 50 times N, 24. So answer will be RM 321.09. Next example. To buy a new car, Mr. Hashim decides to save every month into account that pays interest at an annual rate of 5% compounded monthly. If he has 34,442.50 at the end of 5 years, how much he has to save? So in this question, we have to find the value for R. So list down all the information given. So what we have here, J equal to 0.05, M equal to 12, T equal to 5 years, S equal to 34,442.50. Therefore, I equal to 0.05 over 12 and equal to 12 times 5 equal to 60. So S is given by the formula R, 1 plus I to the power of n minus 1 over I. So substitute all the value. S equal to 34,442.50. R that we want to find, 1 plus I, 0.05 over 12 to the power of n, 60 minus 1 over I, 0.05 over 12. Therefore, R equal to RM 506.46. A corporation wants to establish a sinking fund beginning at the end of the year. Annual deposit will be made at the end of the year for the following 9 years. If deposit earn interest at the rate of 8% per year compounded annually, how much money must be deposited each year in order to have RM 12 million at the time of the 10th deposit? How much interest will be earned? So list down all the information given. S equal to 12 million. J equal to 0.08. M equal to 1. N equal to 10. So S is given by R, 1 plus I to the power of n minus 1 over I. So S here is 12 million. R that we want to find, 1 plus I. I equal to J over M. So we have 0.08 to the power of n, 10 minus 1 divided by 0.08. So R will be equal to RM 828,353.80. So interest earned equal to S minus R times N. So equal to 12 million minus R 828,353.86 times 10. Answer will be RM 3716,461.40. Next example. Safwan intends to invest 10,000 per year for 3 years on a fund that offers an annual interest rate of 10.5%. He has two choices to choose from. The first choice, deposit 10,000 at the end of each year and the interest compounded yearly. The second choice, deposit 2,500 every 3 months and the interest compounded every 3 months. So every 3 months means compounded quarterly. Which investment is more profitable? So first we look at the first choice. So choice number 1, S equal to R 10,000 times 1 plus I 0.105 divided by 1 to the power of 3 minus 1 over 0.105 over 1. So answer will be RM 33260.25. Choice number 2, S is given by 2,500, 1 plus 0.105 over 4 to the power of 12 minus 1 over 0.105 over 4 equal to RM 34733.59. Okay, so choice number 2 is more profitable. Alright, for this example, at the end of every month, Mr. Zaki saved 200 in an account that pays an annual rate of 10% compounded monthly. After 3 years, he adds 60 ringgit to his saving per month. Show that the total amount after 6 years is 22,129.17. So here, Mr. Zaki saved 200 for 6 years. Okay, and then after 3 years, he add 60 ringgit. So 60 ringgit is for 3 years. Okay, so let us draw a timeline. Okay, timeline for 6 years. So we have 1, 2, 3, 4, 5, 6 years. Okay, so the interest rate J equal to 10%. Okay, so for 6 years, okay, Mr. Zaki saved 200. So R equal to 200 and equal to 12 times 6 equal to 72. And then after 3 years, starting here, he start to save 260, meaning he add more 60 ringgit. So R equal to 60 and equal to, for 3 years, 12 times 3 equal to 36. So here, the accumulated amount is S1 and here is S2. So we have to show that S1 plus S2 equal to 22,129 and 70 cents. Okay, so let us calculate the amount for S1 and S2. So S1 plus S2 equal to, for S1 R equal to 200, 1 plus I 0.1 over 12, N equal to 72 minus 1 over 0.1 over 12, plus S2 60, 1 plus 0.1 over 12 to the power of 36 minus 1 over 0.1 over 12. So when we calculate, S1 equal to 19,622 and 26, S2 equal to 2506.91. So the total will be RM 22,129 and 17 cents. So shown.